So let's go over to the next problem, example number 2. We have already decided that the parabola is facing down. First, I need to be able to find my vertex, which is 0, 0. There's no h or no k. We'll see one on the back, example number 3, we'll have an h and a k. But in this case, we have 0, 0. It's my vertex. Now, I need to find my focus. In order to find my focus, I need to find out how far it is from the vertex, and that'll be the value of p. So I need to be able to find p. I'm going to let 4p, just because the formula has a 4p, 4p must be equal to negative 1. It should be negative 3. I solve for p, I divide by 4. That cancels, so p is equal to negative 3 over 4. Remember, 3 over 4 is 3/4 is less than 1. Negative 3/4 is about negative 0.75, or we can deal with fractions. Now, I'm just going to make a quick sketch so I know what the parabola is facing. It's facing down, just like we decided. So it'll be not negative 1, it's just negative 3/4 will be around here, and that'll be my focus. Now, my directrix will be on the opposite side, 0.75 or 3/4, and that'll be my directrix. Your directrix will just be a line. In this case, it's a horizontal line. It's crossing the y-axis, so this will be y is equal to positive 3/4. Now, I need to be able to find points on the parabola, so I can have a more exact parabola. I'm going to plug in this case, I'm going to plug in values for y. So I'm going to let y is equal to, you always want to go inside your parabola, so I'm going to plug in a negative 1. If it was facing up, then you will have to plug in a 1 and then a 2. In this case, I'm going to plug in a negative 1 so I can find both points on the side. So let y equal to negative 1. That will give me x squared is equal to negative 3, but instead of the y will be a negative 1. X squared is equal to positive 3. And then I'm going to take the square root on both sides. The square root and the square cancel, so x is equal to square root of 3. We know the square root of 3 is between the square root of 1 and the square root of 4. And it's approximately 1.7. And let's not forget our plus or minus. So that'll give me 2 points. Both of the points, the y is negative 1. The corresponding x value, one of them is 1.7. The other one is negative 1.7. And I'm going to go and plot both points. I'm going to go to the right 1.7 and then negative 1. Then negative 1.7, 1.7, and negative 1. So that's my parabola. It's a little wider than I thought. I need to find another set of points. So I'm going to let y is equal to, I'm going to go down one more, negative 2. That will give me this point and this point. So I have x squared is equal to negative 3, but instead of the y will be a negative 2. That will give me x squared is equal to 6. To get rid of the square, I'm going to take the square root on both sides. The square and the square root cancel, so x is equal to the square root of 6. Now let's go and, what is the square root of 6? The square root of 1 is 1. That's too low. The next perfect square, 2 squared, that's 4. 3 times 3 is 9, so the square root of 9 is... So the square root of 6 is between the square root of 4 and the square root of 9. So it'll be about halfway done. So we can just do 2.4 or 2.5 is fine. Let's do 2.4. And that'll be plus or minus. Let's not forget the plus or the minus. That'll give me 2 points. both of the points, the y value is -2. The corresponding x value, one of them is 2.4, the other one is -2.4. And I go and plot both points. So I'm going to go to the right, 1, 2.4, and down -2. And to the left, 1, 2.4, and down -2. And that'll be my problem. Facing down. I'm going to erase my previous sketch. The sketch is just to help you guys visualize where should be the focus and what numbers to plug in. It's very helpful. Let's go over to the back side. On example number 3, we have decided that it's facing up. Now, first thing I want to be able to find is my vertex. In this case, that'll be -2 and +1. So -2 and +1 is here. I need to find the value of P because that will tell me how far my focus is from my vertex. So find P. I'm going to let 4P is equal to 12. It always equals to this number. So you always going to let 4P equal to this number, and that will give you the value of P. I'm going to divide by 4 on both sides. That will give me P is equal to 3. Remember, it's facing up. So I'm going to make a quick sketch. So that means my focus has to be inside the parabola. So I'm going to go 1, 2, 3. That'll be my focus. This is my vertex. And my directrix will be on the opposite side. 1, 2, 3. You'll be a dashed line. And the equation, it's crossing the y-axis. So the equation will be y is equal to, where is it crossing the y-axis? At -1, -2. So y is equal to -2. That's the equation for the directrix. Now I need to be able to find different points on the parabola. Because the y is on the right hand side, I'm going to let y is equal to different values. So I'm going to let y is equal to, I'm always going to go inside the parabola, so I'm going to go from my vertex inside. What is the y value? That is 2, right, correct? So from here, I'm going to go inside, and that is the corresponding y value. I'm going to let y equal to 2, and that will give me this point and this point right here. That is, make sure you write small because this is a longer process. X plus 2 squared is equal to 12. Instead of the y will be a 2 minus 1. That'll give me x plus 2 squared. This is 2 minus 1 is 2. This is 2 minus 1 is 1. X plus 2 squared is equal to 12. Now I can get rid of the square by taking the square root on both sides. That'll give me x plus 2 is equal to plus or minus the square root of 12. Let's say I know that the square root of 9 is equal to 3. That's too low. The next perfect square is the square root of 16, which is 4. So the square root of 12 is between square root of 9 and square root of 16. So it's right almost in between. So let's just say 3.5. Next, I need to leave the y by itself. I'm going to go and move my 2 to the right, becomes a negative. We have x is equal to -2 plus or minus 3.5. That'll give me 2 points. One of them will be excuse me, both of them, the y value, we have 2 on the y value. For the x value, one of them will be -2 plus 3.5. The other one will be -2 minus 3.5. So one with the positive, one with the negative. If I simplify, this will give me -2 plus 3.5 is 1.5, comma 2. The other point will be -2 minus 3.5 is -5.5, comma 2. I'm going to go from my origin, 1.5 and up to, and -1, 2, 3, 4, 5.5 and up to. So there's my parabola. I need to find another set of points. So I'm going to let y equal to, I went up 1, I'm going to go up once again, so y is equal to 3. Let y equal to 3. And I'm going to go and plug it in. That is x plus 2 squared is equal to 12. But instead of that, y will be a 3 minus 1. That will be x plus 2 squared is equal to, this gives you 2 times 12 is 24. I'm going to take the square root on both sides. The square root cancels the square, so we have x plus 2 is equal to plus or minus, and this is an approximation. That should be the case on all of them. Square root of 24 is very close to 25, so just square root of 25 is 5, so this will be 4.9. And the last step is to move my 2 to the right, becomes a negative. So I have x is about -2, that becomes a negative, plus or minus 4.9. And that will give me 2 points. The y value for both of them will be 3. The corresponding x value, one of them will be with -2 plus 4.9. The other will be -2 minus 4.9. So it gives me 2.9 comma 3. And the other one will be -6.9 comma 3. Those are individual points that I need to be able to plot. I'm going to go to the right, 1, 2.9 and up 3. Now from my origin, I'm going to go to the left, 1, 2, 3, 4, 5, 6.9 and up 3. So we have our problem. Don't forget to draw your directrix, write your equations, and label your focus in your vertex as well. So this one's one more challenging just because it requires a bit more work for the points. But if you just do it step by step, it should be fine.